So what if there was just like a single algorithm capable of learning absolutely anything?
Right, which sounds totally wild.
Yeah, it does. And I don't mean a highly specialized system that just plays chess or generates images. I'm talking about one foundational mathematical equation that could predict human behavior, discover novel scientific breakthroughs in physics, and, potentially reshape the entire structure of human civilization.
It sounds incredibly hyperbolic, honestly, like the setup for a mid-century science fiction novel or something.
Yeah, totally.
But the reality is, this is the very real, very earnest pursuit of modern computer science. Like the entire field is quietly racing toward this one singular goal.
Well, welcome to this deep dive. Today, we are immersing ourselves in Pedro Domingos' foundational book, The Master Algorithm.
It's such a fascinating read.
It really is. And our mission here is to move past the surface level buzzwords surrounding artificial intelligence. We're going to examine the mechanics of how machine learning is actively shifting our reality from a world of hard-coded programmed rules into a world of fluid systems that actually learn from raw data.
Hmm.
We're going to deconstruct the different philosophical approaches to AI and then figure out how you can apply these underlying frameworks to your own career and decision making.
Because the mechanics of this technological shift are actually the mechanics of problem solving itself.
Right.
If you can understand how these systems process information to find solutions, you develop a completely new lens for understanding the economy, technology, and, well, even human psychology.
Okay, let's unpack this shift from programmed intelligence to learned intelligence. Most of the people listening to this are already familiar with the basic premise of machine learning, but I think it helps to establish a baseline of how the mechanism actually flipped.
Yeah, definitely.
So think about old school software engineering like giving a computer a highly unforgiving recipe for a cake. You have to write down every granular step in sequence.
Right, it's super rigid.
Exactly. If your code forgets to specify crack the eggs before adding them to the flour, the computer just throws whole eggs into the bowl. It possesses zero intuition. It only executes explicitly defined logic.
And machine learning basically flipped that paradigm on its head.
Right. Instead of giving the computer the recipe, you give it like 10,000 pictures of perfect cakes, 10,000 pictures of burnt cakes, a mountain of raw ingredients, and you program it to figure out the recipe on its own by spotting the structural differences between success and failure.
And while that sounds simple conceptually, the implications of that flip are what created the entire modern tech landscape.
Yeah.
The reason this paradigm shift became the new engine of human progress is purely due to the limits of human cognition. We simply cannot manually write the rules for reality. I mean, reality is just too messy.
It's way too messy.
Take a natural language processing system. If you try to manually code a rule for every single way a human being could sarcastically say the word great, your code base would be infinitely long.
Oh, absolutely.
Because language relies on context, tone, regional dialect, history. Manual programming fails the moment it encounters a variable it hasn't seen before.
It's too brittle. Like a rule-based system just snaps under the weight of real-world complexity.
Precisely. But a machine learning system doesn't need rules. It needs examples. It absorbs millions of hours of raw audio, mathematically mapping the acoustic patterns to the context of the words. It derives the rules internally.
Yeah.
And this exact same mathematical mechanism is what allows these systems to analyze medical imaging, for example.
Right, because a human radiologist is limited by the number of scans they can personally review in a lifetime.
Exactly. A machine learning model can ingest 10 million MRIs overnight, cross-referencing pixel variations against long-term patient survival rates.
That's just staggering scale.
It spots microscopic subpixel correlations that indicate early-stage pathology. Correlations that human eyes literally cannot perceive.
And human programmers could never manually define,
Exactly.
which fundamentally changes the core resource of the global economy.
Hmm.
Because if the system is deriving its own rules by looking at examples, then the system is entirely dependent on the volume and quality of those examples.
Hmm.
Data is no longer just a byproduct of software.
No, data is the actual fuel. It's the cognitive raw material.
Yeah.
Without a massive influx of data, the most sophisticated machine learning algorithm in the world is essentially a brilliant brain locked in a dark, empty room.
Ooh, that's a creepy image.
Right. It can't learn anything. This is why the infrastructure of the internet is designed to capture every micro interaction. Every time you pause on a video, every time you click a link, every time you alter your GPS route, that is fuel.
It's constantly feeding the machine.
Yes, it's being actively pumped into probabilistic models to make them more accurate at predicting human behavior.
But instead of just looking at that as a macroeconomic trend, let's pull that down to the individual level.
Mm-hmm.
We tend to view data as this abstract commodity hoarded by massive server farms.
Mm-hmm.
But your habits, your daily workflow, your financial decisions, that is your personal data.
Mm-hmm.
And if intelligent systems rely on a continuous data feedback loop to optimize their performance, human beings should probably operate the exact same way.
It's the concept of treating your own life as an observable system. Like a learning algorithm improves because it constantly measures its predictions against reality and adjusts its internal weights.
Right.
If you aren't measuring your own outputs, how you spend your time, what triggers your stress, where your money actually goes, you are essentially operating like that old school, rigid, programmed software.
You're just executing the same code every day without allowing the data to update your behavior.
You're flying blind, hoping the recipe still works even when the ingredients have changed.
Okay, but here's where I really need to push back on the broader narrative of AI. We talk about machine learning as if it's one monolithic thing. If data is the universal fuel, and the goal is just to spot patterns, why isn't there a consensus on how to do that? I mean, math is math, right? Shouldn't there be one definitively correct mathematical architecture for processing all this data?
You would think so, but intelligence turns out to be incredibly fractured. There isn't just one way to be smart.
Interesting.
Domingos outlines that the entire field of AI research is essentially divided into 5 distinct tribes. And each tribe has a fundamentally different philosophy on how a machine should learn.
So they're basically rival factions.
Basically, yeah. They are looking at the exact same data, but processing it through completely different mathematical mechanisms.
So walk us through these factions. How are they approaching the problem differently?
Okay, so the first tribe is the symbolists, who rely on logic. Their philosophy is that all intelligence can be reduced to manipulating symbols and rules.
Okay, rules.
But instead of a programmer giving them the rules, they use a process called inverse deduction to figure out the rules themselves.
Wait, inverse deduction.
Yeah. So if the system knows that Socrates is human, and it knows that all humans are mortal, it can deduce that Socrates is mortal. That's standard logic.
Right, classic philosophy 101.
But in machine learning, inverse deduction works backward. If it knows Socrates is human, and it knows Socrates is mortal, it hypothesizes the rule. Ah, humans must be mortal. It fills in the missing logical premises.
Oh, I see. That makes sense for highly structured environments, like playing a board game or organizing a database. But I feel like logic is terrible at nuance. Like it really struggles with ambiguity.
Which is exactly why the second tribe, the connectionists, entirely dismisses logic.
Really? Entirely.
Yep. This tribe focuses on neural networks. They believe that to build intelligence, you have to reverse engineer the human brain. Instead of writing discrete rules, they build layers of artificial neurons.
Okay, let's actually visualize how that works for a second, because the term neural network gets thrown around constantly.
It really does.
The way I like to picture it is like a massive, complex system of water pipes. The data is the water. When the network makes a mistake like identifying a picture of a dog as a cat, the system works backward through the pipes, slightly tighten the valves that led to the wrong answer, and widening the valves that led to the right one.
That is a brilliant analogy. The technical term for that tightening and widening of valves is backpropagation.
Backpropagation, okay.
The network constantly adjusts the weights of the connections between neurons based on its errors. Over millions of cycles, the pathways become perfectly optimized to recognize a dog.
But there's a catch, right?
A big one. The connectionists have a glaring problem. Their systems are black boxes.
Right.
Because the knowledge is distributed across millions of tiny adjustments in the network, the AI can't explain why it thinks the image is a dog. It just knows it is.
Right, which brings us to the third philosophy, which always strikes me as the absolute most chaotic, the evolutionaries.
Oh, yes. The evolutionaries believe that the only intelligence we know of that actually created a brain was natural selection.
So they just simulate evolution in code.
Exactly. They create a massive population of random algorithms and test them on a problem. Most of them fail miserably,
Obvious.
but the ones that perform slightly better are selected, and their code is literally spliced together, mutated, to create a new generation of algorithm.
Wow.
Over thousands of generations, you breed highly efficient code that human engineers could never have even conceptualized.
But the drawback there has to be computational waste.
Hmm.
I mean, evolution in the real world took billions of years and involved an astronomical amount of death.
A lot of trial and error, yeah.
Running genetic algorithms must require an immense amount of trial and error before you get anything remotely useful.
Exactly. It's incredibly resource intensive. That brings us to the fourth tribe, the Bayesians, who focus on probability.
Okay, probably.
The Bayesians look at the world and say everything is uncertain and logic is an illusion. They use Bayes' theorem to calculate the probability of a hypothesis being true, and then they continuously update that probability as new evidence arrives.
So this is how a spam filter works, right?
Yep, perfect example.
It doesn't have a hard logic rule that says if the email contains the word lottery, it is definitely spam. Instead, it calculates the statistical probability. Like, given that the last 10,000 emails with the word lottery were spam, there is a 99.9% chance this new email is also spam.
Spot on. It handles uncertainty beautifully. But Bayesians struggle to create entirely new concepts. They are heavily reliant on their initial assumptions or their priors.
Okay, so what's the last one?
Finally, we have the fifth tribe, the analogizers. Their mechanism is all about recognizing similarity. If you encounter a new situation, you figure out what to do by finding the most similar past situation in your memory.
How does a machine mathematically determine similarity, though? Like, what does that look like?
Through multidimensional mapping. A technique like the nearest neighbor algorithm takes a new piece of data and plots it on a massive multidimensional graph.
Okay.
It then simply looks for the data points physically closest to it. This is exactly how recommender systems on streaming platforms work.
Oh, really?
Yeah. If your viewing history plots you into a specific coordinate in their data space, they look for the nearest neighbor, another user who is plotted right next to you, and they recommend whatever that person just watched.
Okay, so we have the symbolists using inverse deduction, the connectionists suggesting the weights of neural networks, the evolutionaries mutating code, the Bayesians updating probabilities, and the analogizers mapping out similarities.
That's the landscape.
Looking at this array of philosophies, this is a phenomenal mental model for everyday problem solving. When you are facing a massive roadblock in your career or a complex personal conflict, you're likely failing because you're just stuck in one tribe.
It happens constantly. People get deeply attached to one analytical framework.
You might be trying to solve a management issue using pure symbolist logic, just enforcing strict workplace rules. But you're completely ignoring the Bayesian probability of human unpredictability.
Exactly.
Or you're relying entirely on analogy, this is how we solved it last time, and missing the fact that the environment has mutated.
The most effective thinkers intuitively cycle through all 5 of these frameworks. You have to evaluate the logic, recognize the network dynamics, calculate the probabilities, look for analogies, and allow for evolutionary experimentation.
And that realization that no single framework is sufficient on its own is what drives the central thesis of Domingos's work, right?
Yes, exactly. If each triad has discovered a mathematically sound but incomplete piece of the intelligence puzzle, what happens if you build a system that incorporates all 5?
This is the holy grail, the master algorithm.
A single unifying mathematical formula. An algorithm that uses evolutionary mutation to discover the best network architecture, uses backpropagation to adjust the weights of that network, uses Bayesian probability to handle the uncertainty of the data, uses analogies to map similarities, and outputs the final result as clean, deducible logic.
If that kind of theoretical unification is actually achieved, the compounding effects would be difficult to even conceptualize. Because currently, scientific disciplines are heavily siloed. The people studying quantum physics aren't necessarily communicating with the people studying genomic sequencing.
Right, they're in completely different worlds.
But a master algorithm wouldn't be bound by human departmentalization. It could ingest the entirety of the world's scientific data simultaneously. It could mathematically map the analogy between a subatomic interaction and a biological mutation, discovering foundational laws of reality that exist entirely in our blind spots.
It essentially becomes an engine that invents engines.
Wow.
Domingos emphasizes that this pursuit highlights the supreme value of systems thinking. A master algorithm is basically the ultimate attempt to find the underlying pattern beneath all observable complexity. And there is a profound takeaway here for you, the listener, regarding how you structure your own knowledge.
Which is really about finding leverage, right? If you only memorize facts, your knowledge is fragile. It breaks the moment the environment changes.
Exactly. Memorizing facts is like writing that brittle, old-school software code. But if you focus on understanding the deep systemic mechanisms of your industry, the core incentives, the psychological drivers, the physical constraints, you develop a master framework of your own.
I love that.
When you understand the underlying mechanism, you can pivot across entirely different domains because you recognize the same structural patterns repeating themselves everywhere.
I see the power in that, absolutely.
Yeah.
But contemplating a system that is that capable, that all-knowing, it brings me to a place of genuine existential discomfort.
I think everyone feels that.
Right. If we are marching inevitably toward an algorithmic architecture that can learn anything from data, process it perfectly, and cross-reference the entirety of human knowledge in a fraction of a second, where do we fit?
It's a huge question.
How does a biological human being who needs 8 hours of sleep and occasionally forgets where they put their car keys justify their economic or societal value in the face of raw, infinite computational power?
It is the defining economic anxiety of our generation. And the reality we have to accept is that the nature of human value is permanently shifting.
Permanently.
Yes. If you attempt to compete with a machine on its own turf, meaning memorization, calculation, data processing, or pattern recognition at scale, you will lose.
It won't even be close.
It won't even be a contest. The sheer volume of variables a unified learning algorithm can hold in its working memory dwarfs human capacity.
So trying to outcalculate the machine is just a dead end. We have to pivot our entire strategy.
The shift is from competition to amplification. The future belongs entirely to those who understand how to collaborate with these systems.
Collaboration, not competition.
Exactly. A master algorithm might be able to discover a cure for a disease by processing a billion variables, but the algorithm doesn't have a moral compass. It doesn't inherently understand human suffering, ethics, or meaning. It lacks agency.
It needs us to point it in the right direction.
Yes. It relies entirely on humans to provide the objective function, the why, and the what we should care about.
It's the concept of treating AI not as a competitor, but as an exoskeleton.
Oh, that's a good way to frame it.
Like a physical exoskeleton amplifies your biological muscles so you can lift a car. An algorithmic exoskeleton amplifies your cognition so you can process a million data points. But the human still has to decide where to walk and what to build.
Precisely. Let's go back to the radiologist example from earlier.
Okay.
The radiologist who refuses to use the AI because they are afraid it will replace them will absolutely be replaced.
Right.
But they won't be replaced by the AI itself. They will be replaced by another radiologist who uses the AI to scan 10,000 MRIs and then uses their human empathy, their understanding of the patient's family history, and their ethical judgment to decide the best course of treatment.
So your value in this new landscape comes from your ability to synthesize the machine's output with human context.
That's the key. The ultimate currency is human adaptability.
Which brings us full circle. If the machines are characterized by their ability to constantly update their models based on new data, we have to adopt that exact same operating system for ourselves. You have to become a relentless, continuous learning system.
It is the only defense against obsolescence.
Yeah.
You have to update your internal weights and biases just as fast as the environment changes.
Let's pull all of this together to see the whole board. We started by exploring the massive tectonic shift in computer science, moving away from explicit programming where we write the rules, toward machine learning, where the system observes the data and derives the rules itself. We explored why data is the literal fuel for this new engine. We broke down the 5 distinct tribes of AI, the symbolists, the connectionists, the evolutionaries, the Bayesians, and the analogizers, and uncovered why relying on a single mental model basically guarantees failure.
And we examined the quest for the master algorithm, this mathematical unification of all those tribes into one ultimate learning system. And finally, we confronted the reality that resisting this intelligence is futile. Our survival really hinges on using it as a cognitive exoskeleton.
It is a profound reshaping of how knowledge is generated and applied. But before we wrap up, I know you always look for the hidden implication in these texts. What is the final thread from Domingos's work that we should be pulling on as we sign off?
Well, it goes back to that fundamental premise. These algorithms require massive amounts of data to learn.
Right.
Right now, these systems are just gorging themselves on the entirety of the human historical record. Every digitized book, every podcast transcript, every medical record, every line of code we've ever written.
That's all getting sucked in.
And this is the catch: human data is finite.
Oh, right. There's a hard cap on how much we've actually produced.
Exactly. So what happens when a master algorithm consumes it all? when it reaches the absolute limit of the human data
I
exhaust.
mean, what does it do?
The only way for it to continue learning is to begin generating its own synthetic data, creating its own simulations, and training on the outputs of its own models. Wow.
So I want you to sit with that thought today. What does our reality look like when the ultimate learning system is no longer learning from us, but is entirely bootstrapping its intelligence from itself? What kind of alien logic does it develop when humans are no longer the blueprint? That is a deeply unsettling yet incredibly fascinating place to land. I mean, if these algorithms are currently limited by the biases and structures of human thought, removing the human data entirely might result in a form of intelligence that operates on dimension that we literally just can't perceive.
It's definitely something to think about.
Thank you for joining us on this deep dive into the master algorithm. Remember to track your patterns, leverage multiple frameworks for your problems, and keep evolving your mental models. Catch you next time.